We used to look at Venus and think, tropical, wet, steamy, maybe even alive. Not because we had proof, but because those clouds looked like they were doing us a favor. Like a sunshade. Like a blanket. Turns out it was a lid. A pressure cooker lid. Venus isn't hot. Venus is what happens when a planet turns itself into an oven and then sits on the door. By the time probes started dropping in, the truth was brutal. A runaway greenhouse so extreme the surface sits around 475 degrees Celsius. And the air presses down with roughly 90 times Earth's pressure. That's like living under a kilometer of ocean, except the ocean is carbon dioxide and it's trying to cook you. And the early Soviet probes? They didn't malfunction. They got crushed. The first big problem was simple. Everyone's numbers were wrong. In the late 1960s, the accepted model said Venus might be around 20 atmospheres. High, but doable. Reinforce the structure, beef it up, send it in. So they did. And the probe stopped transmitting while it was still tens of kilometers above the ground. Not because it burned up. Because the pressure up there was already enough to collapse it. That's when the engineers realized Venus wasn't going to be spacecraft engineering. It was going to be submarine engineering for hell. They tried a workaround first. Make the probes fall faster. Smaller parachutes. Less time being roasted and squeezed. Didn't help. They still imploded above the surface. So for the next generation, they built an armored capsule, a forged pressure vessel designed to take far more than they expected. And even then, Venus still got a swing in. On Venera 7, part of the descent system failed. Instead of drifting down gracefully, the thing basically dropped like a stone and hit the surface hard. Mission Control thought it was dead. It wasn't dead. It had fallen over. And because its antenna wasn't pointing nicely at Earth anymore, the signal wasn't obvious. It was buried in noise. But when they went back through the recordings later, they found it, a pattern, a faint, stubborn transmission. They recovered about 23 minutes of surface data, humanity's first confirmed signal from the surface of another planet. It was basically a tipped-over tin can, screaming in slow motion. That proved the mission concept could work. But then came the next killer, temperature. Because pressure you can brute force with metal. Heat is more patient. At 475 degrees Celsius, standard electronics don't get glitchy. They die. Quickly. Permanently. And insulation doesn't solve it, it just delays it. You can't radiate heat away either, because the outside is hotter than the inside. A radiator on Venus is like trying to cool your tea by holding it against a kettle. So the Soviets did something clever and grim. They treated the lander like a timed bomb. They pre-cooled it. Started the internal system below freezing, a cold block thrown into a furnace. Then they filled it with a phase change material, something that soaks up heat by melting, buying time while the electronics work. Not survival. A countdown. 50 minutes. Maybe an hour. If you're lucky. Now, the cameras. Everyone expected the surface to be basically pitch black. 90 atmospheres. Thick cloud cover. Surely no light gets through. So they added floodlights, just in case. And when the lens caps popped, they realized the surface wasn't dark at all. It was bright enough to see, like an overcast day. The atmosphere didn't block sunlight completely. It scattered it. Soft, diffuse, eerie. Then the images started assembling line by line, because they weren't using a normal camera system. Too fragile, too risky. So they used a scanning approach, a mechanical mirror sweeping across the scene and turning the landscape into data. Numbers, telemetry, a slow-build panorama. And when the first panoramas came back in 1975, they weren't what people expected. Not smooth dunes, not a wind-scoured desert, jagged rocks, sharp edges, angular debris, which told scientists two things instantly. One, the winds near the surface were surprisingly weak, because those rocks hadn't been sandblasted into pebbles. Two, parts of the surface might be geologically young. Then, in 1982, came the shots people remember, color panoramas. And they didn't reveal a rainbow alien world. They revealed something worse, orange. Everything. The rocks looked orange. The ground looked orange. The sky looked orange. The horizon looked orange. Not because the camera broke, because Venus is basically filtering sunlight like a planet-sized Instagram filter that only lets the warm colors through. To prove it, they even included a little color calibration chart, and it came back wrong in exactly the way physics predicted. Whites looked orange. Blues turned dark. If you stood on Venus, you wouldn't see color the way you do on Earth. You'd see a world stuck in sepia. And here's the part that's almost comedy. One of the later missions had a mechanical arm designed to test the soil, to see if it was soft dust or hard rock. The mission lands. The lens cap pops off, and it lands in the exact spot where the arm is programmed to strike. So the arm comes down and proudly measures the hardness of Venus by hammering a piece of the probe it brought from Earth. After millions of kilometers, re-entry, crushing pressure, and furnace heat, it lost a fight to its own lid. There's also the infamous life controversy that popped up decades later, people reprocessing the old panoramas, claiming strange objects appeared and disappeared. But the more grounded explanation is simpler. The lander itself was cooking, warping, shedding parts, melting insulation, shifting slightly in the heat. Venus wasn't showing wildlife. It was showing the machine dying. And that's the part that should bother you. We've roved Mars for years. We've mapped worlds at the edge of the solar system. Yet the closest planet to Earth? Our only true ground-level photos are from the early 1980s. Everything else you see of Venus is radar, reconstruction, or cloud tops. So yeah, we went to hell. We saw it. And then we stopped looking.